Hello everyone, hopefully you're doing well. In this video, we're going to continue with chapter 2, equations, inequalities, and problem solving. In the previous videos, I'm pretty sure you saw that we went over, linear equations in one variable. We introduced you to problem solving. We solve, problem solving, you solve for a specified variables as this chapter focuses on equations, inequalities, and problem solving. So we're going to take a look on inequalities. We're going to start with linear inequalities and let us go over problem solving. So the objectives in this section is to use interval notation. We solve linear inequalities using the addition property, solving linear inequalities using the multiplication and addition properties, of course, and solve linear inequalities using both properties of inequality. And at the end, we would solve problems modeled by linear inequalities. So anytime we talked about inequality is a statement that contains the symbols of less than, you know, you have less than or less than, like three. Three is less than four, or five is more than two, right? And if we said like 11 over 2, all right, or 3.5, 3.5 is less or equal to 3.5, because that's less than or equal to, there is a possibility less than, this one, this one, this one, less than or equal to. And this one right there is more than or equal to. Well, you have all the different terms to use. Okay, not exceed, is at most, is no more than. You have so many expressions you can use to express inequalities, but inequalities is the absence of equality, that is the absence of equations. But, even though you see these symbols not equal to, not equal to is also inequalities. So when, like, the difference between equations and inequalities, let's say, for example, x is equal to 3. But if I said x is greater than 3, equal to 3, you need to be more than 3 years old to be admitted to this park, so you can enter this park. More than 3 years old. That means if you are exactly 3, you're not gonna be part of it. All right. Equations, for examples, you can see 12 equals 7 minus 3y. That's equations. But if I said 12 should be less than or equal to 7 minus 3y is inequalities, right? So inequalities can be 2x minus 1 can be between 0 and 6, then I would need to solve for x all the time. So you see, both ways you can solve for x. If I said 3x minus 5 equal to 8. So you see, equal equations is one thing. Inequalities, you need to be at least or more than. Now, let's see, do use some interval notations to express it. Um, you know, a solution, graphing a solution of inequality is a value of the variable that make the inequality a true statement. For example, if I said, if the solution set of an inequality is the set of all equations. Now, it all depends of what we want to do. For example, if we want to do, let's say a graph, we have the equations, inequalities, x greater than 3. Now graph, I can go on a number line. I identify where is 0, 1, 2, 3, 4, 5, etc. On the left of 0 is -1, -2, -3, etc. And these arrows means we can continue indefinitely. Now, if x is greater than 3, this is 3 right here. So I can put a parenthesis. I'm going to explain that later. Why parenthesis? Because parenthesis, if you have less than or greater than, use parenthesis. If you have less than or equal to, or greater than or equal to, you use a bracket, okay? So we're gonna see that later. Now, we said x must be greater than 3. That means the parentheses mean 3 is not included. Maybe 3.0001 is included, but not 3. Everything above 3 is in it except 3. But where we should stop, we cannot stop because it said greater than 3. Even though you have a million, it would be in it, in the solution. So that's why we just put an arrow with like this, so said we can continue indefinitely. This is we can call it, if we want, a solution set. That's a graph. We can also use set builder notation, right? So we can use set builder notation because different ways of expressing the same thing. So set builder notation, we can say the solution is x such that x is greater than 3. This is the set builder notation. And then you have the interval notation. It's different way of presenting the solutions of an inequality. Interval notation. Now, for the interval notation, you see, we can start at 3 with parentheses because 3 is not included. Where we're going to stop? There is no stop because, if you said greater than 3, 100 is greater than 3, true, 20,000 is greater than 3, 3 billion is greater than 3, the US debt is also greater than 3, then we're going to go indefinitely on the right. So we use parentheses. 3 ways to present the solution set of an inequality. We can graph it. We can use set builder notation, or we can use interval notations. Now, what's the difference between using parentheses and bracket? You see here, x, suppose the solution is A, solution is A. So if this is the set builder notation, for us it's like x is really, for this one is x is less than A. You see less than A, we go to the left. And that means we come from negative infinity to A and with parentheses. Now, you see here, x is greater than A, like I did with the 3. You see, we start with A to the positive infinity. Now, if we said less than or equal to, we no longer use parentheses, we use a bracket. You see that bracket means less than or equal to, or you can say greater than or equal to. Again, here we use bracket from the left to right or right to left. But you can have something in the middle. Let's suppose that you have x is between 2 and 5. On a number line, we know 0 is right there, and 1, 2, 3, 4, 5, etc. So you can continue indefinitely because the solution is between 2 and 5. You see, the solutions would be somewhere here. All right. And then if it was less than or equal to, like you see here, we're not going to use parentheses, we're going to use bracket. All right. So you see different ways of expressing and or presenting the solutions. We can use set notations, set builder notation. We can use graph, or we can use interval notation. Three different ways of presenting the exact same solutions. Now, let's go with an examples very quick. We have the first exercise. It said graph each set of on a number line and then write it in interval notation. So first of all, look at the first one. We can say that x is greater, x is really greater or equal to 2. First of all, on the number line, we identify 0, 1, and 2. Okay, we said that we're gonna go, is greater than 2. Should we use parentheses or bracket? We're gonna use bracket because it says greater than or equal to. So we use bracket open to the right. So we're gonna use bracket open to the right. So we show the solutions will go this way. For these reasons, all right, the interval notation, interval notation would be we start at 2 going to infinity, close parenthesis. The second one, remember, x is less than -1. So on the number line, what we need to do, first of all, identify your 0, and you go -1 on the line. But they said less than -1. Less than, that means because we have only strictly less than, we're going to use parentheses open to the left because we're going to go to the negative infinity. So this way, we know for that one, answer would be negative infinity and -1 parentheses. We use parentheses, do not use bracket. Okay, we use parentheses, do not use bracket. Now, the third one, as you can see, they give you the answer in set builder notation. That's why I do the other two, not the set builder notation. The answer is already given in set builder notation. So what we see for the third one is x is between 3 and -0.5. So you see on the left, if you construct and you have 0, 1, 2, 3, 4, 5. I'm gonna just do one that has more space, right? Let's do it with more space. Sorry. 1, 2, and 3. I'm gonna go leave it that way, but you can always put the arrows to show that you continue indefinitely from both ways. All right, there is no boundaries. Now, we identify 0.5. 0.5 is between 1, 0, and 1, and we identify 3. Now, because the symbols between 0.5 and x is strictly less than, we're gonna use that parenthesis. We're gonna use parentheses, and then we're gonna use is less than or equal to 3. So 3 would be in it. So we're gonna use bracket. So we're gonna have parentheses for 0.5 and bracket for 3. Now, answer would be right in the middle up there, and how to express it in interval notations. Whatever you see on the graph, that's not negative. That's only 0.5 and 3 bracket. One side bracket, the other side we're not using bracket because we know it's strictly less than. All right. Now, how to solve linear inequalities using the addition property. The addition property of inequality, if A, B, and C are real numbers. Now, we said if A is less than B, then A plus C is less than B plus C. Now, so let's say, for example, if 2 is less than 5, which is true, so if you do 2 plus 3 would be also less than 5 plus 3, right? So it doesn't change anything. So these inequalities are all equivalent. See in another examples, you say solve x minus 2 is less than 5. Now, first of all, we need to solve it. I mean, how to solve it? We can add 2 to both sides. So if you add 2, because solving means you isolate the variable. So x would be less than 7. Now, what we are asked to do is to graph the solution set. So how to graph the solution set? Remember, the solution here is x such that x is less than 7. So we call that presentation set builder notation. They also ask us to graph it. On a number line, suppose this line is very straight. If we have 0 here, we can count 1, 2, 3, 4, 5, 6, 7, right there. We said x is less than 7. Less than 7, less than mean we use parentheses, and we're gonna go to the left. This is the graph, this is the graph. Questions that they didn't ask that we could also include is the interval notation. So because they could ask us to use the interval notation. They didn't ask me here, but I would show you. It would be negative infinity and 7, both parentheses, because they are not included in our answer. We can see another examples very quick. Oh, here, combine like terms. We need to subtract 2x from both sides to make sure that we isolate the x and bring all x's on the left. 3 minus 2 is only 1x plus 4 greater than or equal to negative 6. Now let's get rid of the 4. Remember, if you have addition, you need to subtract. If you have subtraction, you need to add. So because we have plus 4, we subtract 4 from both sides. So x 4 minus 4 is gone, greater or equal to negative 6, negative 4. Two same sign, you add and keep the sign. So we have the solution set. If we want to write the solution set in the, set builder notation, we can say x such that x is greater or equal to negative 10. Now, in order to graph that, what we do, we go on a number line, we put 0 and we go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. We have negative 10 right there. Now, what they ask you to do, they said x should be greater than or equal to negative 10. That means negative 10 is included. Should we use parentheses or bracket? Yes, we're going to use bracket because we're going to be greater than negative 10. So we're going to go to the right indefinitely, but I put that arrow to show that. But again, they don't ask that questions. They could ask you for interval notation as well. All right, questions that they didn't ask. But if they ask you for interval notations, answers will be negative 10 and positive infinity. Remember where to use bracket and where to use parentheses. On infinity, we always use parentheses. We always use parentheses on infinity. Other objectives we pursue in these sections, we need to learn how to solve linear inequalities using the multiplication and addition properties. If A, B, and C are real numbers and C is positive, then if you multiply, like if you have, if 2 is less than 5, it's equivalent to 2 times 3 less than 5 times 3. So it's the same thing. It would still be less than, they are equivalent. If A, B, and C are real numbers and C is negative, now that's something different. Remember, if we have 2 less than 5, now look what's gonna happen if you have 2 times negative 3, that will give you negative 6, and 5 times negative 3. What's happened? That you switch the sign. Remember, now you're going to have negative 6, negative 15. With a negative sign, the number, even though it's bigger, it becomes smaller. So you need to inverse the inequality symbols. So that's why anytime you have a negative in front of the x term, when you solve to get rid of the negative, you switch the inequality symbols. For examples, if I have 2x plus 1 is less than 6x plus 7, the first thing I do, if I subtract 1 from both sides, so I end up, that's an example, I end up with 2x less than 6x plus 6. Now look at that. If I have 2x less than 6x plus 6, now if I subtract 6x from both sides, I'm going to have negative 4x less than 6. Now, to solve, I need to divide both sides by negative 4. Because I subtract, I divide by negative 4, it's gonna, I'm gonna have only x left because I divide by negative 4. But this inequality symbol will switch to make it negative, greater than negative 6 over 4. That you can simplify by 2. So x would be greater than negative 3 over 2. You see, you can switch the inequality symbols anytime you feel like it's working for you. Okay, now look at these examples. They ask you to solve. I have 1 over 4x is less than or equal to 3 over 2. The first thing I'm going to do is to identify the denominator from both sides. I have 4 and 2. What is the least common denominator if I have 4 and 2? Yes, that would be 4. At this point, I'm going to multiply the left side by 4, and I multiply the right side by 4. Okay? So now I end up having 4x over 4 less than or equal to 12 over 2, because 3 times 4 is 12. Now, 4 over 4 is x less than or equal 12 over 2. It's going to give me the most beautiful 6 ever. Now, this is the solutions that I can put into set builder notation. Remember that we can use set builder notation to express is x such that x is less than or equal to 6. Or I can graph it on a number line. If I have 0, 1, 2, 3, 4, 5, and 6. Now, what it tells me is that it should be less than or equal to 6. So we cannot go over 6. So we're going to use bracket because 6 is also included. So we go to the left. So this is the solution for this one. Or that's the graph, of course. Or if you want, you can use interval notation. Different ways to express exactly the same thing. Interval notation, we're gonna have negative infinity and 6 bracket. We never close on infinity, so that's what never happen. Another example is very quick. Oh, this is what I was talking about. Negative 2.3x is less than 6.9. How to obtain x? Yes, you need to divide both sides by negative 2.3. 2.3. Now, when we cancel this, we only have x here. Now, what's happened with the inequality symbol less than? Yes, it's switch. It's no longer less than, it's going to be greater than, because the coefficient of x was negative. Now, in order to do that, we divide by negative from both sides. So 6.9 divided by negative 2.3 gives you a beautiful negative 3. All right, so that's the solutions. Set builder notation, we can say x such that x is greater than negative 3. Or you can use the graph. Sometimes they're going to ask you to use all three, but sometimes they ask you to use only one of them. So x must be greater because it's simply greater than, we're going to use parentheses. All right. And then we can also use interval. They don't ask for it, but we're going to put it interval notation. We're going to say is -3 infinity. Again, on infinity, we always put parentheses. If you're happy with that, and I think I'm gonna be happy also, but we do have another objective to pursue in these sections is solving linear inequalities using both properties of inequalities. The first thing is to review how to solve linear inequality in one variables. First of all, we clear the equations of fractions by multiplying both sides of the inequalities by the least common denominator of all fractions in the inequalities. Second of all, we use the distributive property to remove grouping symbols such as parentheses. We combine like terms on each side of the inequality. We use the addition property of inequality to rewrite the inequality as an equivalent inequality with variable terms on one side and numbers on the other side. Fifth step, we use the multiplication property of inequalities to get the variable alone on one side of the inequality. We always solve for the variables to be on one side by itself. That's why we isolate it either using addition, subtraction, or division. Now, look at that examples. They ask us to solve this one and present it into the graph set. The first thing to do is to distribute distributive property because we need to combine the like terms, but on the right, there was a parenthesis. So 5 times x gives us 5x. 5 times -1 gives us -5. Okay. When you look at on the left and on the right, you notice we have x from both sides. So what we can do, we can subtract 5x from both sides. 3 minus 5 gives you -2x plus 9 greater or equal to -5. What we can do also here again is isolate the x term. In order to isolate the x term, what we need to do is to subtract 9 from both sides. Okay, let's subtract 9. If we subtract 9 from both sides, what we're gonna do is to keep the -2x on one side. Okay, we're gonna keep the -x on one side. Now you see the 9 minus 9 is gone, but we still have our negative, the inequality symbols, greater than or equal to. -5, -9 give you -14. Okay. Now let's divide both sides by -2. Okay. Remember what we just did in the previous examples? Yes, what we need to do is to keep our x on the left. Now, when we cancel the -2, that inequality symbol changed because the coefficient of x was negative. In order to solve for a positive x, we switch the inequality symbol to less than or equal to -14 divided by -2 give you +7. This is the answer. This is the answer. We apply the distributive property. We subtract from both sides for 5x. We subtract for 9 from both sides. All right, and we simplify. We divide both sides by -2. Now, what you see, x is less than 7. So in terms of set builder notation, our solution is x such that x is less than or equal to 7. So this is a solution also. But the goal is to express it on a number line. we have 0 here, 1, 2, 3, 4, 5, 6, and 7. Okay, what they ask you to do, x must be less than or equal to 7. Remember, 7 is included. We're going to use bracket, and because it's less than, we go into the left. Is that correct? Now, if you're good with that, we can even do the interval notation because we know the answer would be negative infinity 7, and you close on 7. Okay, that's giantly important. We solve it that way. Do you get that properly? If you get it, I think we can even do another examples. Why not doing another examples before we move to the next objective? So here again, it's a giant big one. First of all, you really need to distribute everywhere. You distribute the 7 with x and 2. So that gives you 7x minus 7 times negative 2 give you negative 14 plus x. We're done with the left side. Greater than, how about we distribute that negative 4? Remember, you need to take it with the sign. Negative 4 times positive 5. Negative positive give you negative 20. Negative 4 times negative x. 2 negative give you positive in multiplication. So that gives you 4x minus 12. Now you can simplify because the next step is really simplify. 7x plus 1x give you 8x minus 14 greater than, I see a 4x, negative 20, negative 12. Two negative in addition, so you add and keep the sign, so it's gonna be negative 32. Next step is to combine like terms on one side. So we're gonna combine the x's. We said, oh, you know what? How about we isolate the x? We can subtract 4x from both sides. We end up having 8 minus 4 is 4 left. 4x minus 14 greater than negative 32. Now we can also add 14 from both sides to get rid of 14 on the left. So we can only have left the 4x, only x term. So negative 32 plus 14 give you negative 18. I go fast on this. And if you divide by 4 from both sides to obtain only x, you see that x will be negative 18 over 4 because 18 and 4 has a common factor that we call 2. When you simplify by 2, x would be greater than negative 9 over 2. So this is the answer. If you want, you can rewrite it instead build the notation as x such that x is greater than negative 9 over 2. Or why not just divide and express it in decimal? But we prefer to leave it that way. Now, on a number line, remember when they asked you to graph, because that's the goal, graph, they said, okay, we have 0. Remember 9 divided by 2 give you 4.5, right? So we're gonna have negative 1, negative 2, negative 3, negative 4, negative 5. So negative 4 here. So 9 over 2 obviously would be somewhere here. That's negative 9 over 2. Now we know it's going to be greater, giantly greater than the other ones you've been doing. Greater than x must be greater. That means we're gonna go with parentheses from left to right. Okay, I put it so you can see it. Okay. Now, in terms of interval notations, it's gonna be negative 9 over 2. Yeah, if you still need more examples to do that, yeah, just do the homework because you're gonna have plenty of homework you can do to help you remember all of this. We're gonna conclude with solving problems modeled by linear inequalities. If I mean, I'm gonna maybe make this one smaller so we have enough space. Can we do it like If you can read 20, I'm fine. Okay, let's do 20. We said you are having a carded event. You can spend at most $1,200. The set the setup fee is $250 plus $15 per person. So, you can, you can spend, well, you rent the place, or I don't know, $250. That's a flat fee. And the $15 is variable, is plus $15 per person. So if you have 25%, that's gonna 15 times 25 plus 250. But because you don't know the number of people, you can let X be, or let's X represent the number of people, be the number or represent the number of people. Okay. Now, we know it's going to cost you $250 plus 15 times X, because if you know the number of people, remember that if you know the number of people, then you can just substitute X for X, all right? Now, we said find the greatest number of people that can be invited and still stay within the budget. So we want to make sure when you pay the $250 flat fee plus the $15 per person, it shouldn't exceed $1,220. That's the maximum money you can spend. Setup fee plus cost per person times the number of people must be less than or equal to 1,200. So you are having a category event, so that's how we're gonna do it. So now we must solve. Let's solve for it. We can subtract the 250 from both sides. So far, you know how to do that because we need to isolate the X term because now we have only 15 from both sides, on the left only. So 1,200 minus 250, that would give you probably 950. Okay. Now, if you divide both sides by 15 because we're dealing with product, we're going to see 950 divided by 15, that give you 63.3. Now, can we because you cannot invite 0.3 people, it's only on TV. You heard, you heard 2.5 men, but on real life, it's either 2 men or 3 men. So we cannot have like 0.3 people. We either have 63 or 64. The problem, if we go 64, let's see. If you try to go 64, we're gonna do that. If we do 250 plus 15 times 64, we're gonna be 250 plus, let me grab my calculator and see how we're gonna do it. We do 15 times 64, give you 960 plus 250. That give you 1,210, but your budget is 1,200. So meaning you cannot do 64. You must take only it must be equal to 63. So you should invite only 63 people, because if you do 250 plus 15 times 63, now it would be 250 plus 15 times 63 give us, hold on, 15 times 63 give you 945 plus 250 give you $1,195. So you're gonna, on your budget of $1,200, you're gonna have only $5 left. If you want to add one more people, you need to add $10, right? So in this particular case, we would conclude the number, all right? We're gonna set the number of people who can be invited must be, see, I use must be 63 or less to stay within the budget, right? To be in the budget or less to stay within the budget. If you go 64, then you're gonna go over the budget. I hope you're doing pretty well with this section as well, where we solve for, we solve a lot of linear inequalities and we do one problem. So strongly advise you to work in linear assignments just to improve and do more exercises on these sections so you can master more skills on inequalities. In a different video, we will come back for compound inequalities. Hope you enjoyed this and let me know if you have any questions.